दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, welcome to the online class of chemistry. I am Aryan Panda. Last class I taught you what is valency and how to find out the valency of the atom of an element from the periodic table. So valency is defined as a number which determines the combining capacity of the atom of an element with respect to hydrogen is 1. The number of atoms of hydrogen which combine with one atom of the element is the valency of the element. But later on, after the discovery of the fundamental particles and the development of structure of atom and the atomic number and discovery of the rare gases, a theory was developed on valency by Cosel called as electronic theory of valency, where the valency is defined as the number of electrons can be lost or can be gained or can be contributed and shared by the atom of an element to attain octet in their outermost shell. And the group number indicates the number of electrons present in the outermost shell. So the valency of the atom of an element can be equal to the group number or 8 minus group number. Either group number or 8 minus group number. The group number indicates the highest valency state an atom of element can exhibit. So all the elements of group 1 have one electron in their outermost shell, are called as alkali metals, placed in S block of the long form of periodic table, are called as alkali metals, exhibit valency 1. The elements belonging to group 2A are called as alkaline earth metals, have 2 electrons in their outermost shell, exhibit valency 2. Then coming to the P block, group 3A elements have 3 electrons in their outermost shell, so they exhibit trivalency. The boron, aluminium, gallium, indium, thallium, all are trivalent. The elements belong to group 4, carbon, silicon, germanium, tin, lead. They have 4 electrons in their outermost shell, 2 electrons in their s orbital and 2 electrons in their p orbital. So they exhibit highest valency they can exhibit is 4. Carbon is a non-metal, silicon is a non-metal, germanium is a metalloid, tin is a metal, and lead is a metal. And this germanium, tin and lead, they also exhibit valency 2. I explained you last class that this is because of inert pair effect, because in s orbital the 2 electrons are paired and p orbital the 2 electrons are unpaired. They can easily come out and take part in chemical combination, hence they exhibit valency 2. And when all the 4 electrons they take part in chemical combination, they exhibit valency 4. So germanium exhibit 2 valencies, germanium 2, 4, tin 2, 4 and lead 2, 4. Then coming to group 5, they have 5 electrons in their outermost shell, so they have a strong tendency to gain electron, and hence these elements are called as exhibit electronegative character, and the elements are nitrogen, phosphorus, arsenic, antimony, bismuth. They exhibit valency 3 and valency 5 because they can accept 3 electron and attain octet, hence they exhibit trivalency, and they have all the 5 electrons. If they get involved, then they exhibit pentavalency. Coming to group 6, oxygen, sulfur, selenium, tellurium, polonium and oxygen, they have 6 electrons in their outermost shell, have tendency to take 2 electrons easily to attain octet, hence they exhibit valency 2. Mostly the valency exhibit 2. Also can they have the maximum valency they can exhibit is 6. Now coming to group 7, the elements are fluorine, chlorine, bromine, iodine, astatine. They have 7 electrons in their outermost shell, hence they have a strong tendency to accept an electron in their outermost shell and attain octet, hence they are exhibiting valency 1. And all these elements have a strong highly electronegative, and because they can accept electron very easily and their affinity for electron is also very high, hence they are called as electronegative element. Fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine is a solid at normal temperature and pressure. Now the elements belong to D block, which are called as transition elements. If you come to the periodic table, last class I have discussed, this is called 1A, 2A, they are called as S block. This 3A, 4A, 5A, 6A, 7A and 0 group, they are called as P block. And these 3B, if I am talking to modern periodic table, 3B, 4B, 5B, 6B, 7B, then 8B and 1B and 2B, they are called as the transition elements, and all these elements are highly electropositive. They are otherwise known as transition metals. They exhibit variable valency because they have electron in the d orbital, in degenerate d orbital. Because of the presence of electron in the degenerate d orbital, they exhibit variable valency. So we have seen the case of iron, known as ferrum, has 2 valencies, ferrous plus 2 and ferric plus 3. Coming to mercury, mercurous plus 1, mercury, if you come to the mercury, you see here the copper, silver, gold, zinc, cadmium, mercury. Mercury is in 2B, so it has it exhibit 2 valencies, mercurous 1 plus 1, mercuric plus 2. Now when you come to 1B, copper, silver, gold, the copper exhibits valency Cu plus 1, valency state Cu plus 1, the cuprous, and Cu plus 2, cupric. Similarly, if you come to the 7th group, we have 7th B group, we have manganese. Here is a scandium, titanium, vanadium, chromium, manganese. So here manganese exhibits, it has 7 it exhibits valencies, large number of valency states, that is plus 1, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. But out of them, it has 3 valency states which are very prominent, plus 2, plus 4 and plus 7. And coming to chromium, here is the chromium, atomic number 24. It belongs to 6B group of the long modern periodic table, and here it has 6 electrons outermost shell, s orbital 1 electron and d orbital 5 electron. So it exhibits valency 1, valency state, I am using the word valency state 1, 2, 3, 4, 5, 6. But out of them, plus 2 state and plus 3 state and plus 6 state are prominent. And similarly, when you come to the vanadium, atomic number 25, it exhibits valency plus 5 and plus 3. So all these elements are there when we will studying the periodic table. In a periodic table class, we will vividly discuss about it. My point is, instead of remembering the valencies and forgetting them and struggling with them to remember, very easily we can find out the valency state and valency of the elements from the periodic table. Now in this class, we will go to another important term in chemistry we are using, and that is called radical. Radical. So this radical word is not a chemistry word. atom of the elements, they are exhibiting a peculiar character. What? Atom, when you come electrically neutral, take part in chemical combination. But there is a reactive state in atom. The reactive state of atom, to explain the reactive state of the atom, is called as a radical. For example, sodium is a metal, sodium atom. But sodium ion, sodium is what? It is, if you come to the here, you will look to this, sodium is placed in group 1A of the periodic table. It has atomic number 11. So electron configuration 281, it has one electron in its outermost cell. So it is strong tendency to lose electron, to become 28, the neon configuration. So reactivity. So to explain that, after losing electron, it becomes stable. So when you come to sodium, just I am giving you here one example. I am giving you sodium, its atomic number is 11. So there are 11 electrons, 2, 8, 1. So what this will do? It can lose this electron very easily to become 2, 8. What is the 2, 8? The structure of neon. The structure of neon, inert gas. So it loses an electron and forms sodium ion. Now if you compare the two states, here it is atomic state, this is here it's an atomic state, and this is its ionic state, and this is reactive. This Na plus is stable to become, but Na plus is a positive ion. We know that positive ions attract negative ion, positive ions repel positive ion. So this state is called as a radical state. So this ionic state, they use a general term from English language. They borrowed the word radical. Radical means very reactive or very progressive. Radical. So this is a word used in English. They borrowed that word to explain the reactive state of the atom and combination of atoms. Hence this word radical was borrowed to explain this. Then how we define radical? An atom or group of atoms. Group of atoms. An atom, it may be an atom or it may be group of atoms with a charge on them, acting as single unit, is called radical. So it may be an atom or it may be group of atoms. It may be an atom or a group of atoms. And what will happen to them? They will have a charge. They will have a charge on them. So charge means it may be a positive charge or it may be a negative charge. We have two charges, positive charge, negative charge. When positive charge, when an atom loses electron, forms a positive ion, carries a positive charge. When an atom gains an electron, it forms a negative ion, so it will carry a positive charge or it will carry a negative charge. Or a group of atoms, sometimes a group of atoms, they combine, they act as a single unit and they have a charge on them, hence they are called as radicals. Because in a molecular effect, why this definition came? For example, if you come to water, H2O, it has two atoms of hydrogen and one atom of oxygen, and here in water hydrogen is present. What is property of hydrogen gas? Hydrogen is combustible. What the property of oxygen? Supporter of combustion. But the moment you come to water, water is neither combustible nor supporter of combustion. It is neither combustible nor supporter of combustion. So then what happens? Here water is acting as a single unit, not acting as a hydrogen, not acting as a oxygen. So this is a compound nature. So that may carry a positive charge. For example, carbon dioxide, if you come, carbon, combustible, black in color, solid. It combines with oxygen, 2 atoms of oxygen to form carbon dioxide molecule. And oxygen is supporter of combustion, colorless gas. But peculiarly, when they combine, the total number of atoms are 3. The carbon dioxide molecule, it is neither combustible nor supporter of combustion. It is a gas, and also it is colorless. Hence, it acts as a single unit. So sometimes a compound number of atoms together, they carry a charge. So to explain that character, they use the word an atom or a group of atoms with a charge on them acting as a single unit is called a radical. Now, if you say according to number, we will come to the number of atoms first. So, if you take then what is a radical? So, this, if there is one atom is present in a radical, there will be one atom depending upon the number of atoms. If there is one atom, then this is called as simple radical. If there is one atom is present, it is called as simple radical. And if there are more than one atom, 2 or more than 2 atoms, this is called as a compound radical. This compound is called as a compound radical. When it is a single atom, an atom of an element, it is called simple radical. When it contains 2 or more than 2 atoms of different elements, then that becomes a compound radical. Now this simple radical, if it carries, it may carry a positive charge or it may carry a negative charge. Because what? A charge on them. It may be a positive charge, negative charge. So these radicals, this simple radical, they are called simple, the positive charge, simple electro positive radical, simple electro negative radical. Simple electronegative radical. Now when you come to a compound radical, when this compound radical carries a positive charge, it is electropositive radical. When the compound radical carries a negative charge, it will be a compound electronegative radical. So when the compound radical gets a positive charge, it is called as it carries a positive charge, so electropositive compound radical, electropositive compound radical, and when it carries a negative charge, electronegative compound radical, electronegative compound radical. So an atom or a group of atoms with a charge on them acting as single unit is called as a radical. When it is a radical has one atom, it is called simple radical. And when this simple radical may have a positive charge, may have a negative charge. When it is a positive charge, it is called simple electropositive radical. When it is a negative charge, simple electronegative radical. When it is more than 2 atoms or 2 or more than 2 atoms are present and they carry a positive charge, act as single unit, they are called as electropositive compound radical and electronegative compound radical. Or now if you add them, then it comes what? In total we will classify all the radicals, this simple radical and compound radical. There are now 4 types: simple electropositive radical, simple electronegative radical, electropositive compound radical, electronegative compound radical. So we can say now, to have a very systematic approach to study what is a radical and how to know how to write the formula of radicals, and how to write the charge of the radicals. I don't know. My one thing, children, I always impress upon you that we will not remember anything. We will try to understand with a scientific way. We will approach. So now radicals can be classified in as four types. There are four types of radical. Now will come electropositive, simple radical. Electropositive, simple radical. Then this electropositive compound radical. Electropositive compound radical. Then electronegative simple radical. Electronegative simple radical and electronegative compound radical. We can study in a systematic manner, find out from the periodic table their formula, their charge and all that. So we will not be remembering and forgetting, we will be knowing them. Now this electropositive simple radical, it is a positive. So they are called as cations. And they are called as also basic radicals. So this electropositive compound radical, they are called as cation and they are called as basic radicals. And this electronegative ions, they are called as anion. And they are also called as acid radicals. Why cation? They move to cathode. If you take they are positively charged. In the electrolysis, we have two electrodes. One is a positive electrode called anode, and other is a negative electrode called cathode. They are positively charged, so they will move to cathode. These ions are positively charged. They are attracted towards negatively charged electrode, hence they are called as a cation. Because they have a charge, they are ion. They are attracted towards cathode, hence they are called cation. Then why basic radical? Because these radicals, they combine with OH minus ion to form a base. They form base, and hence they are called as basic radical. They form the base. We will read how they are forming base. We will write their formulae. Simple here, electronegative radical, they are called as anion. The negative radicals, they have negative charge. They will move to the negative electrode, negative charged electrode. Positively charged, they will move to the positively charged electrode. That positively charged electrode is called anode. Positively charged electrode is called anode, hence they are called as anion. They are migrating to anode, hence they are called as anion. And these negative radicals, they combine with H plus to produce an acid. Most of the radicals, they combine with H plus to form an acid. Hence, they are called as acid radical. So, wherever you are having a name, we are, as I was telling you last class, that we are reading, these are called language of chemistry. And we are reading the language of chemistry everywhere. If the positive charge is cation, why cation? Positive charge is basic radical, why basic radical? We will question ourselves. And then question, base. What is a base? An oxide or hydroxide of a metal is called base. Hence, they will these radicals, positive radicals, will combine with oxide ion and they will combine with the hydroxide ion to form a base. Hence, they are called as basic radicals. Then coming to the acid, anion, because they move to anode, they are anions, and they combine with H plus to form an acid. Hence, they are called as acid radical. So now, electropositive simple radical, electronegative, electropositive compound radical, electronegative simple radical, and electronegative compound radical. We will go by one. Now we will come to electropositive simple radicals. What are the two things? They have a one atom. They have one atom with them. They have atom of an element with them, and they have a charge. That is, suppose we write their symbol, we write as B. They are called a basic B. So they have a charge. They have a charge, positive charge. What charge? They have a 1, they have 2, they have 3, they have 4, they have 5, they have 6, they have 7. They can go to anything. They can carry any charge because they have 7 electrons. 1 electron to 7 electrons. So we write B plus N. With the symbol we will what? B for basic, B for basic, charge for radical, and N the number of charge. B plus 1, B plus 2, B plus 3, B plus 4, B plus 5, B plus 6. So their formula, general formula, B plus N. So then who will form simple electropositive simple radical? So what we know, when an atom loses an electron, it forms a positive ion. Why? An atom, the number of electrons are equal to number of protons present in an atom. Hence, atom is neutral. The moment it loses an electron, suppose you have an atom B, it has an atom B. Here number of protons are equal to number of electrons. So our charge is 0. The moment this will lose an electron, the number of protons will be more than number of electrons. Hence this will form B plus. B plus. So if it loses 1 electron, plus 1, loses 2 electron, plus 2, loses 3 electron, plus 3. So then what conclusion we can make? Why remembering? Now what conclusion we can make? Atoms of those elements which can lose electron will form basic radicals. Then atoms of which element? If you go to the octet rule, atoms of every element have a strong tendency to attain octet in their outermost cell, either by losing electron or by gaining electron. So those who have 1 electron, they will lose. Those can have 2 electrons, they can lose. Those who have 3 electrons, they will lose. 4, 5, 6 electrons will also can lose, but lose with difficulty. Hence the 1, 2, 3. Then what we know from the periodic table? The group number indicates the number of electrons present in the outermost cell of the atom of an element in the periodic table. That means if you come to the group 1A, I am talking about modern periodic table. Please don't get, we have 3 types of periodic table I told you. First it came Manley periodic table in the 1869, where elements were arranged according to atomic mass. Then after the discovery of atomic number by Moseley in the year 1913, the elements were arranged according to atomic number. The periodic table, the physical and chemical properties of the elements are a periodic function of their atomic number. So the elements were arranged according to atomic number. That is called as modern periodic table. Then towards 1935-36, the s orbital, p orbital, d orbital, f orbital, all the orbitals were discovered, and their properties mostly depend upon the electron configuration. Hence, according to electron configuration, the periodic table was expanded. That is called long form of periodic table. So the periodic table I have fixed here, it has both. It is the long form periodic table, it is also modern periodic table. If you look here, if you look to the periodic table now, here is 1A. It is written 1A, group 1, 1A. If you come to here, 2A, 2. So 2 according to long form, 2A according to modern. If you come here, 3A, 13, 4A, 14, 5A, 15, 6A, 16, 7A, 17, and 18 is a zero group elements. So very easily you can know this. So now all the elements of group 1 will have one electron in their outermost shell. So they will form what? Simple electropositive radical. So first come to the group 1. Group 1A, I am writing the radical formula according to modern periodic table, which I want to explain. I am using that, so the viewers should not get confused, should not have a doubt, or should not have a mind say periodic table what is 1A. No, I am talking modern periodic table 1A, 2A, like this were there. So that is easy for me to explain you the periodic table and so on. So elements of group 1A have formula NS1, one electron in their outermost shell, so they can lose electron. Then what is the charge? So write the charge is equal to group number. The charge will be equal to what? Group number. So all the elements of group 1, their formula will be what? B plus 1, B plus 1. Who are the elements? Hydrogen, H plus, then lithium, Li plus, sodium, Na plus, potassium, K plus, rubidium, Rb plus, and cesium, Cs plus. So all these elements, they form electropositive simple radical with charge 1. Then coming to group 2A. Group 2A. These elements, they have configuration NS2. They have 2 electrons in their outermost shell. So their charge, they will lose 2 electrons. So they will exhibit charge plus 2. They will form electropositive simple radical with a charge plus 2. So their formula will be B plus 2. B stands for basic radical with 2 positive charge. So they will form beryllium Be plus 2, then magnesium Mg plus 2, then calcium Ca plus 2, strontium Sr plus 2, and barium Ba plus 2. Radium is a radioactive element. I am writing around it, and it will form also Ra plus 2, but is a radioactive element. We are not focusing much on them. So very easily you can know from the periodic table. So what is the charge, what is this thing, all these things you can just predict yourself without remembering them. Instead of remembering Mg plus 2, Mg plus 2, Ca plus 2, Ca plus 2, let us not do that. We go by from the periodic table. Now we'll come to group 3A. Elements of group 3A. So in the modern periodic table, here are the group 3A. In the long form of period, it is 13. In the long form period, it is called boron family. In the long form of periodic table, they are called as boron family B. So here they will be charged, and their formula is NS2 NP1, 3 electrons. S orbital has 2 electrons, P orbital has 3 electrons. So they will exhibit charge what? B plus 3. So who are they? The boron plus 3, aluminium plus 3, gallium plus 3, indium plus 3 and thallium plus 3. So from the periodic table you are simply writing them. Now we'll come to group 4 of the periodic table. Group 4 here, carbon, silicon, germanium, tin, lead. They have 4 electrons in their outermost shell. They can lose 4 electrons, they can also gain 4 electrons. So carbon and silicon, if you come to group 4, group 4 A of the modern periodic table, who are the elements? Carbon, silicon, germanium, tin, lead. And I told you that carbon is a non-metal, silicon is a non-metal, germanium metalloid, tin metal, lead metal. So they form 2 types of radicals. Carbon or silicon, they don't form electropositive radical. Silicon forms electropositive radical, Si plus 4, and germanium forms 2 types of radicals. I have talked to you while discussing the valency, G plus 2 and G plus 4, and tin forms Sn plus 2 and Sn plus 4, and lead forms 2 types of radicals, Pb plus 2 and Pb plus 4. So when there is a lower valency state, their name ends in OUS. Higher valency state name ends in IC. If the name is ending in IC, it is a higher valency state. If the name is OUS, so germanium will call germanious and germanium germanic. Sn plus 2 is called stannous and Sn plus 4 is called stannic. Lead plus 2 is called plumbous and lead plus 4 is called plumbic. So this is the way we come to this group 4. Now we'll come to group 5. Group 5A. Children, we have talked about group 4 elements, 4A elements, carbon, silicon, germanium, tin, lead. They have 4 electrons in their outermost shell. The carbon and silicon, they are non-metals. Germanium is a metalloid, tin is a metal, lead is a metal, and germanium exhibits 2 valency states, G plus 2, G plus 4. Tin exhibits Sn plus 2, Sn plus 4. Lead exhibits P plus 2, P plus 4. Where is the lower valency state? I told you it is OUS, and where the higher valency state is called IC. So germanious, germanic, stannous, stannic, plumbous, plumbic. Now let's come to group 5. If you come to group 5A, in the long form, it is in modern periodic table. But if you go to long form, it is 15. Group 15, they are called nitrogen family. The elements are nitrogen, phosphorus, arsenic, antimony, bismuth. All of them, they have 5 electrons in their outermost shell. So Ns2, they have 2 electrons in s orbital, and Np3, they have 3 electrons in their p orbital. So when they use these 3 electrons, they will exhibit plus 3 valency state. When they will exhibit all the 5 electrons, they will exhibit plus 5 valency state. So nitrogen does not form electropositive radical. Phosphorus does not form electropositive. These 2 will not form electropositive radical. Who will form? These elements will form electropositive radical, because down the group positive character increases. Now it will form arsenic, forms As plus 3 and As plus 5. Antimony forms Sb plus 3 and Sb plus 5. And bismuth will form Bi plus 3 and Bi plus 5. And the lower valence state, lower valency state is always stable state. So these elements, a stable state. So these elements, which one? Group 5 elements, they will exhibit mostly plus 3 state. This plus 3 state is there almost used. Plus 5 is the highest valency state. So generally they will form radicals Arsenius S plus 3, Sb plus 3, Antimonous and Bismuthus plus 3. S plus 5. So mostly they will be using this. And if you come to group 6A, now we'll come to group 6A of the periodic table. In the group 6A, we have, it is the modern periodic table. In long form, periodic table is 16. So in group 6A, we have the elements oxygen, sulfur, selenium, tellurium, polonium. Polonium is a radioactive element, and all these elements have 6 electrons. In s orbital 2 electrons, and in p orbital they have 4 electrons. So they will always exhibit valency 2. So because why? They can take 2 electrons and form this. So here oxygen forms, it will not give electron. And who are they? Now these two are the non-metals. They will form negative radical and they will form the positive radicals. So it will form Se plus 4 plus 2 and Te plus 2. And group 7 elements are highly electronegative. They will not form electropositive radical. So we have discussed the simple electropositive radical. Group 1 will form plus 1, group 2A will form plus 2, group 3A will form plus 3, and 4 will form 2 and 4, 5 will form 3 and 5, 6 will form the 2. So this is the way they form. So next class I will talk to you about electropositive compound radical. In next class we will come to electropositive compound radical, electronegative simple radical, electronegative compound radical. Thank you very much.